All right, today we're looking at interpreting derivatives. Interpreting derivatives is the idea of looking at a graph of a derivative or second derivative or original function and determining something about the graph. Okay? So, starting with this graph, we're given the graph of f prime, and we're asked on what intervals is f increasing or decreasing. Well, f is increasing when f prime is positive. So we're looking for places where f prime is positive. F prime is positive from, well, there we go. Well, my thing seems to be not wanting to work. Okay, let's try that again. F prime is positive. Here, in between these, so there we have a positive f prime. And then over here as well. So, if we're setting up an interval where f is increasing, so it's increasing from -2 to 0, and then from 2, and it doesn't have arrows, so we're going to assume it stops there, so 2 to 3. It's decreasing when the opposite's happening, when f prime is less than 0. So decreasing from -3 to 2, or to -2, and then from 0 to 2. Okay? All right, where is f concave up and concave down? Well, f is concave up and concave down when f prime, or f double prime, is positive or negative, but we don't have f double prime. We have f prime. So we need to figure out what's happening with f prime. Well, f prime and f double prime are related by the derivative. F double prime is the derivative of f prime. When the derivative is greater than 0, then the function before it, the function one level up, is increasing. So really we need to say that f is concave up when f double prime is positive, or when f prime is increasing, or when f prime is decreasing. So we have concave up when it's increasing. If we look, it's increasing from -3 to, we'll say that's -1. So -3 to -1. And then from, and really I should just erase some of these other marks. They're getting in the way. Well, hold on. Okay, well, it's not letting me erase right now. Don't know what is happening. Pen's not working on that side, but it is working on this side, I think. Why is it not erasing? There we go. All right, so looking for where it's increasing. We have increasing from here to here, so that's the -3 to -1, and then from 1 to 3. Decreasing, or concave down, is going to be right here in the middle, from -1 to 1. Okay? Where does f has a relative maximum or a relative minimum? Remember, f is going to have a relative maximum or relative minimum when f prime changes from positive to negative, or from negative to positive. So we have a relative max when f prime changes from positive to negative. That happens right here. So we go from positive on the left to negative on the right. So that's at x equals 0. Now, when it says justify, we have to justify using the graph we're given. We're given the graph of f prime. Our justification needs to use f prime. So x equals 0 because f prime changes from positive to negative. Okay? Then we do the min. Min is going to be the opposite, changes from negative to positive. So we have a min at x equals, we have 1 at negative 2 and 1 at 2, negative 2 and 2, because, and once again, this is stop wanting to write for me, because f prime changes from negative to positive. Positive. This looks like an F. It should be a positive. There we go. All right. Where does F has a point of inflection? Well, if we look back to where we had the concave up and concave down, if F prime has to change signs for a point of inflection, or F double prime has to change signs for a point of inflection, then F prime has to change from increasing or decreasing to have a point of inflection. So we're going to have a point of inflection at any max or min on F prime. So we have a point of inflection at x equals, well, that's negative 1 and a 1, because F prime changes from increasing to decreasing or decreasing to increasing. Okay? And then we look at the last one on this page, which, once again, it's not wanting me to be able to do what I want. There we go. Where does f have its minimum value on the interval 0 to 3 and its maximum? This is where we add some really interesting tricks here, because we're talking about the absolute minimum and absolute maximum. We said we need to know the y values to be able to determine this back when we did absolute max and min the other day. So if we look at this, we know we have a relative min at these 2 points. So at negative 2 and 2. Okay, let me erase and so I can emphasize these. It's still not wanting to work. Don't know why. All right, so we have a minimum here. Now it wants to work. Okay, whatever. Minimum here and here. Those are our relative minimums, negative at x equals negative 2 and 2. We need to figure out where's going to be the absolute minimum. So if we look, we get, well, we're only looking from 0 to 3, so really we're looking just at, well, if I can erase enough. There we go. We're just looking at this one, because we have this point is where, at 0, and we're starting here to here. At 0, we start, okay? We start our measurements. The graph has a negative slope or a negative derivative from 0 to 2. So it's decreasing from 0 to 2. And then from 2 to 3, it's increasing. So that means if it's decreasing on the left side for all the values before it on the left and increasing on the right, this has to be the minimum value. So minimum is at x equals 2. That one's not the tough one. The maximum is the tough one, because you're trying to figure out, okay, if it starts here, starts at 0, and then ends at 3, and we know it has a minimum there, that means we have something decreasing, minimum, and then increasing, something like that. What we're trying to figure out for the maximum is, does it start higher on this side or end higher on this side? And this is where we're going to be looking at how much time it spends decreasing. To determine that, we look at the space that's actually covered. If we look here, just in terms of squares, this only spends about, I would say, half a square at best, being under the x-axis, being negative, which means the graph is only going to spend a very small amount of time decreasing. It's only going to decrease for a very little bit. But then on this other side, we spend, that's more than half a square there, plus this little bit right here increasing. Definitely looks like it increases more than it decreases. So it's going to increase more than it decreased. So our max is going to end up at x equals 3. And we'll talk more about why we look at that space underneath in the future, but for now, that's what we're looking at. Okay, here's some more you can try on this graph, and you can always just ask, send me an email or talk to me when you're in class. So you can stop on this one, try these, and then some more practice as well. This is interesting because it's giving you the second derivative for this one instead of the first. All right, with that, nothing else for you. Y'all have a great day.